My name is Andrzej Wisłowski and I work as a search engineer at Allegro. And today I will tell you how we developed fast real-time document grouping using Solr search engine. I will focus mainly on boosting performance of our search queries, and I will show you how we maintain our Solr search code. So that's the agenda. First, I will set up our business context. I will show you the new challenge we were faced with, and I'll show you the developing process of our plugin in the context of a filter query and a search component. And finally, I will show you how our work ended like as a Solr contribution. So I work at Allegro. Allegro is an online marketplace with over 380,000 sellers. It's the largest e-commerce in Poland. It's the 6th largest e-commerce in European Union. With 15 million transactions monthly, 20 million accounts, and 110 million offers. That makes 20 million unique products. So, to start our story, let's imagine that your girlfriend is looking for a red dress. She enters Allegro site and searches for a phrase, red dress. She now can see a listing of products. She selects one and hovers over selected one, and now she can see links to the variants of these offers with different colors, sizes, or patterns. And so with just 2 clicks, she can get to the offer she wants most. And that's the feature we have delivered. Previously, our listings were longer with all possible offer variants. As you can see on this diagram, that's just on the right-hand side a listing with 2 products. If we present this as a listing with all possible variants with different sizes, it's a few times longer and it's harder to find the right product. So, to sum up the requirements, we had to change the offer listing into a product listing. And as each product, we have to present the best offer. In our architecture, we have a Solr index with documents. Each document is an offer, and in our cases, product contains different offers, and one product can have offers with different titles, different descriptions, different attributes, and even they can be placed in different categories. So as a user enters the listing, they can filter offers by phrases, categories, and attributes. The request to the Solr is executed. It filters the subset of offers, and then it groups those offers into products. So we decided to use a Solr built-in feature, that is Solr collapsing plugin that allows to run collapsing query parser that groups documents by the value of the selected field. We have added to our queries a filter query that executes the collapsing query filter, and as a field by which we wanted to group offers was the product identifier, and we have to also set a sort expression for choosing the best offer that will be presented for each product. To look inside collapsing query parser, it works in a way that it collects document by document. For each document, collect method is executed, and in this method, it is decided whether this offer is the best offer collected so far for its product. If so, that it's saved to the temporary data structure, and after collecting all of the segments with all of the documents, the finish method is executed, and the best offers are returned from our query filter. So we deploy this change on production, run performance test, and we have discovered that the performance test failed to meet our request time SLA. We have found that was the problem due to the high load on garbage collector that was caused by cleaning those temporary data structure that have to be built for every query lister for collapsing offers into product. And the time was when we decided to implement our own version of collapsing plugin. We based our solution on the sorting the index by product. As a result, on every segment, offers of same product were laying next to each other, and as our collapser works, it has to first collect an offer, a document that is an offer, check whether this is a new offer of is an offer of a new product or the same product that the previous document. If so, then it has just to update, save to the temporal variable the best offer for this product that we are collecting. If we collect the document that is the offer of the next product group, we publish the previous best offer for the previous product, and we save to our temporal variable as the best offer for the product P2 the current item. And we have to remember that after collecting whole segment, we have to publish also the last product best offer. And as a result of this algorithm, we resolve the garbage collector load due to no need to memorize a big data structure, as we need only to remember one best offer for the current product. But there were drawbacks also of this approach, as an index consists of many segments. We have collect each segment separately, that there was a possibility that offers of the same product would be placed in different segments, and request to this with collapsing would make repetitions of the same product. And however, in our case, we modify all of the offers of the same product together, so there is a high probability that those documents will be placed in the same segment, but we didn't have a 100% guarantee. So after discussing this problem with business, we had to develop a next version of collapsing parser that's aimed to remove repetitions. And we have one thing I'd like to say, that in our case we built listing with two Solr requests. The first request is for Faceting. That's the building of the red box for the counters of different categories or parameters, and the other request is done for returning the list of IDs for the products to be presented on the page of the listing. We've checked that for Faceting queries, which are lighter, as we do not need to calculate the score or to sort items, we had no problem with performance. And what we had to do, we had to optimize the request that returns the items to build the list on the listing, list for a page, list for links to the products. We thought about using a re-rank query. Re-rank query is a functionality in Solr that allows to develop a re-rank function that would resort the results returned from the Solr query. We thought about developing a re-rank query that would not only sort items, but during sorting it would also group offers into products. But unfortunately, we had discovered that we would need to implement our own Drawbacks collector subclasses, and our code would need to be developed for many Drawbacks collector subclasses, like top fields collector and so on. And the upgrade of Solr, if it changed the implementation of following classes, it would, as a result, it would give us work to rewrite our plugin. So we decided to implement our filter query, as we have discovered that we only need to return a limited number of items to build a page of listing. So our filter query that collapses items needs only to return a limited number of items. So we don't need to have a big temporal data structure. We decided to use a priority queue with limited size to the number of IDs we need to return from the query. Our priority queue was implementing field value hit queue, but was also aware of the identifier of the product to allow us to group offers into product. And we have to remember that our filter has to be executed as the last filter, as it does not return all of the items that can be searched for by our query, but only the subset that is needed to build the page of the listing. So our algorithm works in a way that it collects document by document. For every document it collects, it has to compare this document to the last offer in our priority queue. If it's worse, it just skips this item. If our document we are collecting is better than the last in the queue, we have to check whether in the queue we have another offer of the same product. If so, and if our current document is a better offer than the one in the queue, it replaces it, and run resorting the priority queue, and the last case is when our document is an offer that is better than the last in the queue, and in the queue we does not have another offer of this document. We just replace the last document in our queue and resort it. After collecting all of the documents from all of the segments, the finish function is run, and as a result from our filter, it returns all of the documents that are collected by the priority queue. We deployed this function, this feature to our test environment, run performance test, and they succeeded meeting our SLA needed for request time. But there was one problem. On the listing, we present the number of offers that can be searched by our query, and this number was not the one this number was wrong, because our filter returns only the subset of documents that needed to be presented as on our listing. So in our case, this subset of documents are returned to top docs collector, and there is the place when this number of hits possible to be found by our query is our count. So we had to implement a search component. In our case, our filter saved to the request context variable the appropriate number of products that can be found by our search query, and after running top docs collector, our search component is executed, and this fixes the response number of hits to the appropriate number. What we had to do was to implement a finish method in our collapsing filter, where we added the correct number of total hits, and we had to implement a search component that checks whether this variable in the request context is set. If so, that it fixes the response object, rebuilding it with the appropriate number of hits. And one thing has to be also fixed is the object that is used for application logs, and this number has to be fixed there too. And we have to add in our Solr config our search component definition and add it to the list of components that are executed for the request handler. We ran this change on production, and it was successfully working for 6 months. After that time, our business came with another idea. They want to change our product listing to use two-sort expression. The one for finding the best offer to be shown as a product representant, as the other for sorting the listing. To give you an example, we would like, for example, we would like to show a product listing when for each product we would present a best-selling offer, and the user was allowed to change the sort orders of the listing to the best delivery time or best price or any other sort expression. We tried using the previous implementation, But as the items that are gathered in priority queue, we at the end have to resort them. So as a result, for each request, the size of the priority queue has to be the size of possible products that can be found for this query. And as a result, our performance test failed with the pressure on a heap too big to meet our request time SLA. And we decided to modify our collapsing query parser once again. First, for our product identifier, we use a string identifier. And we would like to check whether changing this identifier to a number type identifier would make our request faster. We use murmur-free function to generate a number type from our string identifier, but unfortunately, for our case, integer space was not enough. And we found that collapsing query parser given by Solr only allowed to group documents by the field of type string, integer, or float. And so we implemented in this collapser grouping by long type field, run performance test for this change. But unfortunately, we did not see any significant improvement. And that time I went on holiday and returned with a new idea. I have found that in our case, the first sort expression that selects the best offer for a product does not use the score, whereas the second one uses it, and collapsing query parser given by Solr executed a scorer for every document that was sent to our filter, and not only for the one that are effectively collected. And in our case, for our queries, on average, product has 32 offers, so up to 32 times the scorer was run too often. I prepared a change that runs scorer only for the documents that are effectively collapsed, and performance tests shown that we gain a 30% query time decrease. And as a result, this feature, we have prepared a contribution to Solr that was effectively merged into version 8.1. And now I'm about to finish. And to sum up the lesson we've learned, Solr is a very flexible tool that allowed us to modify it in many ways, boosting the time of the queries and changing query handling. Maintainability changes on a plugin level is quite easy, and if we contribute this change into Solr, we've got no cost, and we have proved that our change that did not change the Solr syntax was accepted by Solr community fast and neat. And that's all for today, and thank you for listening. I'm ready to take your questions. Thank you. Yeah.
The original version that worked for 6 months, is that submitted at all, or do you have that anywhere as well?
We did not decide to contribute it. We have just it in our plugins, as we have changed. We have used some of the code that is used in the top docs collector classes, so it wasn't so easy contribution.
So did you thought about changing the architecture of the index instead of implementing such complicated, let's say?
I haven't said it, but we thought about it on the first steps. But in our architecture, the products offers can vary with different titles, attributes. So in the end, the product index would need to have subdocuments for different offers for searching them with different attributes. So we decided it would be better to just stay with the offer index, and also our business decided to run it for some queries and for some not, so we would need to stay with 2 indexes.
Another question, can you tell us what's your SLA for the query performance?
I can tell that for percentile 75 it was about 10 or 15 milliseconds. Okay, so thank you.